Hello all, hope you are doing good. This is Mani and I am back with another video. In this video, we will discuss about typical data pipeline on a very high level. As data engineers, we build data pipelines to move data from different source systems into analytics system, that is a data warehouse or a data lake. These sources can be database, a CRM system, or API that generates data for us, or even streaming data that we receive continuously. So what is a data warehouse? Data warehouse is a centralized data repository for a company or an organization where we store all the data that is coming in from various sources from every team or every business unit into one single place. This helps us to perform large scale analytics on very huge volumes of data and extract value out of it. Now that we understood what is a data warehouse and what does a data pipeline do, we will understand it much more elaborately with an example. We will discuss first about what is data pipeline with what all stages it has, and we will also understand about what is ETL and ELT, what are the key differences between a data warehouse and a data lake. Without further ado, let's get started. At this point, we know that data engineering pipeline will help us bring data from different sources into our data warehouse or a data lake. So now we will improvise this definition a bit more so that we understand what does a data engineering pipeline does in practice. Data pipeline is a series of interconnected systems where the data flows in only one direction, as you can see in the above picture. It starts from the source layer and the final destination for that data in our data pipeline is either staging layer or the serving layer. The data flows in only one direction, that is source, raw, staging, and then serving. Also, the clarity and the value in the data will increase when we are passing the data between these layers. What do I mean by that? When we receive the data from different sources or one source, we may end up getting duplicate records in that particular batch or in that particular instance. A data pipeline will be designed in such a way that it eliminates any problematic records, not just the duplicate records, and we will only pass the data that is either requested by the external stakeholders, internal teams. This is the preferred way of building or maintaining the data pipelines to bring the data and to serve the data to different stakeholders. That being said, now we understood that data pipeline will help us bring the data, curate the data, and serve the data. Now we'll understand how each layer will perform in this particular exercise. The first step is the sources. Sources are the systems that either generate the data or record the data or provide the data for our pipeline. Sources can be either a database or an API or file server which periodically sends us a file, maybe daily or hourly within a schedule. And also we can have a streaming data. Not all sources will be included in one single pipeline. We will have multiple pipelines for each kind of source that can be logically grouped. This logical grouping will be done by our business requirements or our understanding of the processes. We will have a particular schedule for each source for data extraction. This schedule will be based on when the stakeholders are expecting the data or end users are expecting the data to our final layers, be it staging or be it a serving layer. Now, once we extract the data, the first layer of storage or first layer in the data warehouse that we store the data is our raw layer. A raw layer is a place where we store the data from different sources into a designated location for each source, and we store the data from these sources as is. Suppose, let's say we are extracting the data from database. We have extracted till today, and if the schedule is to extract data every day, tomorrow we will extract the data, we will extract the records that are generated from yesterday till today. So this is an example how the extraction is done, and once the extraction is done, we will store that into a designated location in our raw layer. And once the data is extracted and the data is in the raw layer, we will not perform any operations directly on the raw data. Any analysis that we want to perform, let's say when we are building a pipeline and we don't know much about the data, if you want to perform any analysis or check the data, we should not touch the raw data at any point in the life cycle of the data. We have to copy the data to some other location, maybe within the raw layer, start our analysis, like kind of fields it has, what kind of data types each field has, what kind of data we are receiving, whether it's a very sensitive data, whether it contains any PII or personally identifiable information of any particular customer or an entity. We have to understand every aspect of that particular data when the data is received in the raw layer for the first time. Once we know all the aspects of the data, we will start building the further processes like cleaning or transforming the data and loading into staging layer or serving layer. Once the data is in a raw layer and all analysis is done, and we have requirements from the end users on how we should proceed with the data, we will start cleaning, transforming, and standardizing the data that is in the raw layer and load it into the staging tables. Staging tables resemble that of the database tables that we extract from the source databases. But staging tables contain all the historical data that was present in the database tables or any other sources as well. What do we mean by cleaning, transforming, and standardizing here? Any records that are problematic or that are not needed by our downstream users or any stakeholders, we will not include them in the staging layer. These are the operations that we will do in terms of cleaning. Once the cleaning is done, if the business requirement is to rename the column in certain fashion, we will do that. So this is one of the transformations. Also, if we want to change the data types, we will do that as well. Again, there will be different types of transformations that are business specific or even platform specific. Later, we will standardize the data. Let's say if the data from different geography is coming in with a different currency, we want our data to be standardized or have one single currency for all the price related columns or fields in the staging layer. These are all the operations that we will perform in the transform layer or the staging layer. And once these are done, we will load them into the staging table. Staging layer help us unify the data from different sources. Let's say we have an orders table where we have orders data and or purchase data. We also have received an API response from one of the payment gateways about or order confirmation. Our downstream users want this data along with the orders data as well. We will parse the JSON files or JSON responses from that particular payment gateway that we have received in our system, and we will convert that into a relational table format, and then we will join with the original orders table so that we have both the data present side by side for every order. These are the few aspects of staging layer. Last but not least, staging layer will try to retain as much information as possible from our raw layer without including any problematic records. Now, since we have discussed about the staging layer as well, we are left with the serving layer. Serving layer will have the business metrics like weekly reports or any business metrics that we want to calculate that requires a lot of data crunching to be done. We don't want any external system to be doing this because it involves a lot of data in the first place that is again sourced from the staging layer tables. Since the data warehouse or analytical system will have much more robust data infrastructure to handle these kind of workloads, we will perform this alongside with the staging table transformation. Once the staging table transformations are done, in the same job we will start working upon building the metrics for the fresh data that is incoming. For example, this is done automatically within the same pipeline. For example, serving layer might have information about the highest purchase categories for an e-commerce website, or what is the turnaround time for our orders that are placed by customers. These metrics help the business improve, but they also require a lot of data to be crunched. So these are done on the data warehouse side. Once they are done calculating, we will load it into different tables than the staging tables. These are called serving layer tables. The serving layer tables can be sourced to a BI dashboard or a report or even to a machine learning model. Most of the times, machine learning model will start sourcing the data from our staging layer. A lot more data with good amount of clarity. So these are the different stages that we typically see in any data engineering pipeline or pipelines. Now that we understood what are different layers in a data pipeline, we will understand what is ETL. So as we have discussed that each data source will have their own schedule of either producing the data, or we will have our own schedule bringing in the data from these particular sources. As data engineers, we should be mindful of how to bring the data and produce the end result, be it a staging table or be it a report that is expected by the end user. Suppose, let's say, a business report is required by a team every day around 12 o'clock. We should estimate how much time it would take to extract, apply all the transformations, and generate a business report and serve or place that report in a particular location. As a data engineering team, we will have to schedule this process of extracting, loading, and transforming the data, right? So this process is called as ETL, or extract, transform, load. Every process will take certain amount of time. As a rule of thumb, we will add some more buffer to it and then place the file or the report before the scheduled time. So ETL is one process that we use. We will also use modified version or a somewhat similar version called ELT. ETL is much more suited in the transformations are minimal and we can place the data as is in a staging layer table, namely the data from a database where we see very minimal changes or transformations that needs to be done. Hardly we will change the data types or even the column names and then place it into our transformation layer. Now comes the ELT part. Since the data landscape has matured, since the advent of internet, we have different sources of data and we received much more versatile that is required in analytics. We receive different formats of data as well. When we receive these kinds of data, we might not know how to transform all of that data at once. We will not have every answer to the questions of how to transform so and so data that is coming in. So what we will do in ELT is we will extract the data, we will store the data in the raw layer first, and as and when the business requirements come in and mature over the time, either we will add a column, we will change the transformation logic. ETL is much more suited in a data warehouse environment where we will have a very rigid rules of how we bring in the data, how we transform and how we load it. We will not change the data much in a data warehousing procedure, but in terms of ELT, where it is employed in data lakes where the schema is not set or the transformation is not set, we will see much more dynamic or fluid schema and we will have columns added or removed based off of our requirements. So that is why we need a raw layer source of truth in ELT process. ELT is generally employed with data lakes. Again, we will have tables that are data warehouse like tables in data lakes as well. It's just that data lakes can store different types of data like unstructured data, semi-structured data, and even structured data. This is where the difference between data lakes, data warehouses, what is ETL, ELT comes into picture in our particular data pipeline architecture. This concludes our video. I hope you got something from this one. If you do, please like, share and subscribe this video to help the channel and to keep me going as well. Again, let me know if you want any topics that are to be discussed on this channel. Since this is a growing channel, your feedbacks and your comments mean a lot. And bye for now. Have a great day.